In this lesson, we're going to examine some more periodic functions. We're going to try and solve some problems, examine transformations, and see if we can draw some of the graphs. So let's start with a little example here. The temperature of seawater off the coast of France is given by this equation, where T is your time measured at 6 a.m. and big T is your temperature. And we want to find some things. In part A, we want to find the initial temperature. So how many hours have gone by? 0. So when T is 0, we're going to do the cos of 15 times 0, which is like saying the cos of 0. And we can punch this into our calculator, and if we do that, we get 11 degrees Celsius. And you find the temperature at midday, which should be 12 noon. So 6 hours have elapsed, so the time at 6. So same equation. We're going to do 15 times 6 this time, so it'll be 90 inside the bracket. All right, again, we can punch this into our calculator. Oops, I don't need a bracket over there. Get rid of that. And we should get 14 degrees Celsius. So as the day's gone on, it's warmed up a little bit. Identify the period. What does this mean in terms of the problem? So we said yesterday that the period in the periodic curves comes from our k value. K is the 15. So we want to find the period. Our period is always 360 divided by k. In this case, 360 divided by 15, which comes out to 24. And it actually asks us to explain what that means. Well, every 24 hours, the temperature goes through a cycle. It goes up during the daytime and down at night, and then starts all over again. Which should make sense, right? All right, part D. Identify the equation of the central axis. What does it mean in terms of the problem? Again, we said yesterday our central axis is the c value at the end. So the equation for us will be y equals 14. And our central axis can also be referred to our average. So this is the average daily temperature of the water. Right, it goes up from there, it goes down from there, but on average it's 14. Then we got ourselves the amplitude. We said amplitude is the number out front. So in this case, the amplitude is 3. Notice I'm ignoring the sign. And the sign tells me which direction I start drawing in, but the amplitude is just the value. Okay? So what does it mean? It means the temperature never gets more than 3 degrees from average. I'll go up to a high of 17. I'll go down to a low of 11. That's always within 3 degrees of average. That's a measure amplitude. And then the last part, when do we first reach a temperature of 12? So now we've got a problem to solve. We want to know when does the temperature come out to 12. And here's our equation. So we need to solve it. We can do that like we solve any other equation with a variable. And we're going to isolate that variable. So we get -2 equals -3 cos 15t. Divide both sides by -3. So on the left side here we get 2/3 equals cos of 15t. If I want to get rid of the cos, I can bring to the other side and do the inverse of cos. I'll be left with 15t. So I'll punch that in my calculator, whatever the inverse of 2/3 is. It goes up to like 48.19. Actually, sorry, that's 15t still. I want to solve that for t. We're going to divide by 15, and t comes out to 3.21. Okay, so when do we first reach that temperature? At 3.21 hours after we started. Remember, we started at 6 a.m. So we could say it reaches 12 degrees Celsius at 9 a.m. And we got 21 minutes. Or sorry, 21 times 60 minutes will give us 12 at 9:12 a.m. Okay, there's our starting question. What we want to do today is evaluate that k and that a and that c and see what it does to our function. We're also going to add the fourth letter back in, the letter d. Okay, d is a new thing for us in terms of periodic functions. We know it's still a transformation. Okay, to do our transformations, we can apply things in the same way we always have. Okay, we just need to know our parent function. So we have two of them. You should know your sine table, and you should know your cos table. We're going to transform those tables according to a, k, d, and c. And because these are functions, they work in exactly the same way we always have. A is our vertical stretch, compress, reflect. Okay, k is our horizontal stretch, compress, reflect. D will move things left and right. Here's our new word, okay? We call it a phase shift now. And C is our vertical translation. Remember, the things that affect the y's do exactly the way they look. Things that affect the x's are going to do the opposites. So when we start drawing our arrows between functions, the function is always a times y plus c, and x divided by k plus d. But remember here, it's always the opposite sign. So whatever's in the bracket, take it out, do the opposite. Okay, so we'll try some examples, just to remind us of how this works. So for each of these functions, we're going to state the transformations. So k, d. Okay, k is 4/5, which sounds like I should be making something smaller. But when we divide by 4/5, it's actually the same as taking 5/4. So that is a horizontal stretch by a factor of 5/4. D says plus 180, comes out of the bracket, does the opposite, so we have to move it left 180. And we're also asked to figure out the range of domain, state the amplitude, period, and equation of the axis. So we'll start with the easy stuff. Let's start with the amplitude. And amplitude is easy because amplitude is the A value, which is 1. The period, we already talked about that today, is 360 divided by k, which is 4/5. And 360 divided by 4/5 comes out to 450. It's made it longer. That's why it's been stretched. Here the central axis is the c value. In this case, there is none, so y equals 0. They then want us to figure out the range and domain. We'll start with the domain first. So normally curves start at 0, but our curve has moved to the left 180. So that's our starting point. And we know that our curve has a period of 450. So if I start negative 180, add 450 to that, I get a total of 270. So my domain goes from negative 180 to positive 270. I know where I started because of the shift. I know where I ended because of the length of the period. Okay. My range, I can figure out based on my central axis, my amplitude. My minimum value is always, just down here, my central axis minus the amplitude. Where our central axis was 0, our amplitude was 1, so it goes down as low as -1. My maximum is always my central axis plus my amplitude. So again, I can figure it out pretty quickly and get +1. And there's that function done. You guys try the next one. Okay? Just to point out to you, there's a problem with this one. This question is not set up to go yet because, remember our tricks from before, one thing per bracket. So make sure before you start that you factor. Okay, now we'll try the parts and pieces. What things have happened? The 2. That's a vertical stretch. It's changed our amplitude. The 3 is a horizontal compression. It's changed our period. That's our K. We've gone left or right. That's our D value, and right 40, though it's not part of this part yet. And then our C value at the end here, we've gone down. Oops, I didn't write that in there. Right 40. And then down 5. Okay, there's our parts and pieces, how we transformed it. Let's write down our properties. Our properties go with the transformation, right? So our amplitude, we said we stretched it, so our amplitude is now 2. Our period is 360 over k, and we compressed it. So we divide by 3, we get 120. Our central axis, well, we moved it down 5, so negative 5. And we'll do our domain first. Domain's supposed to start at 0, but we moved it 40 to the right. So now we're starting at 40. Our period is 120 long, so 40 plus 120 makes 160. There's my domain. In my range, I start my central axis, which is negative 5, subtract my amplitude, so negative 7, and negative 5 plus 2 is negative 3. There's our domain range, and all our properties. Okay, last part here, we're going to graph these things. We have to do the transformations. So I see a coast curve. That tells me where to start. X, Y, 0, 90, 180, 270, 360. Coast curve starts at 1, and then it goes down and back up. We're going to transform it according to A and D. We're going to stretch it by 2, and then move it 90 to the right. So if I add 90 to my x's, I'll go up 90, which is kind of nice. And then I double my y's, and then I can graph this. 90 and 2, 180 and 0, 270 and negative 2, 360, 0, 452. And there's my curve. Quick and easy. As long as you know our parent function, know our transformations. And they haven't changed since day 1. Try the second one. You got to pause it, give it a try, okay? In the second example, we have to deal with this function before we're allowed to decide about the transformations. Only one thing per bracket, right? So it's common factor with the half, and we're left with x minus 15 divided by a half is 30. Now we can do our table. So sine table, 0 and 90, 180, 270, 360. Sine starts at 0 and goes up and back down. Okay, everything's dealing with the x's this time. Everything's inside the brackets. So we got to do x divided by a half, which is the same thing as 2x. And then we have to add 30. So I'm going to do 2x plus 30. New table. So 30. 2 times 9 is 180, plus 30 is 210. 2 times 180 is 360, plus 30 is 390. And you'll notice there's a pattern to my x's already. I got up by 180 the first time, 180 the second time. I can actually use that to do the next set if I want to. 570, add another 180, and I'll be at 750. Or I can just keep applying my transformations. My y's we didn't touch, so 0, 1, 0, negative 1, and 0. Now this graph is not going to be great for me, so I'm going to have to fix it a little bit. So 180, 360, my next dash, going up by 90 this time with 450, 540. I need to extend it. 540 plus 90 is 630, plus 90 is 720. I have to go a little bit past that. So it's a big, long, spread out graph. So this is 90, 30. I have to break this into thirds, right? 30 and 60. So 30 and 0 would be right here. I have to go 30 past 180, so about there. I'm up to 1. 30 past 360, and back to 0. 30 past 540, I'm down to negative 1. And 30 past 720, we're back to 0. So this graph has been really horizontally stretched and translated. Okay, and there's our function. A bit of a messy one that time because of the 1/2. It made it really long. All right, last one. It's in a good form. The bracket's all been factored for us. We can go straight to our transformations. We need a coast table. So 0 and 90, 180. 270, 360. Co-starts at 1, goes down and back up. Okay, y things on the outsides, so 2y plus 1. X things on the insides. And we'll make ourselves a new table. Okay, half of 0 minus 60, negative 60. Half of 90 is 45. Minus 60 is negative 15. Again, we can follow patterns if you wanted to. So it looks like it's going by 45. Let's try one more just to check it. Half of 180 is 90. Minus 60 is 30. Yep, going up by 45. So I know the next one is 75, and then 120. The y's, we're going to double them and add 1. So 3, 1, negative 1, 1, and 3. Okay, we're going to do some estimating again. So here's 90, negative 90. Here's positive 90. Breaking it into thirds. Okay, 30, 60, 90. But I also need some 15s. Well, 15 is going to be like halfway between the 0 and the 30, right? 75 halfway between. We have to really do some estimating. Negative 60 and 3 is here. Negative 15 and 1 is right about there. 30 and negative 1. 75 and positive 1. And 120 and 3. So if I'm drawing this graph, I get that shape. Okay, it's been horizontally compressed and moved over, vertically stretched and moved up. All kinds of stuff going on. Okay, and that's the end of that lesson. Okay, some homework you can try, being able to work with some problems, and also being able to draw some transformations of sinusoidal curves.